Many times in life, we want to know what the future holds. And there are ways that we could go about trying to predict the future. We could stare into our crystal ball and see if that reveals anything about what is upcoming. But we can do better with science. When we know the relationship between variables, we can use what we know about that relationship for prediction. Because the best predictor of future behavior is past behavior. So let's start with some definitions so we'll all be on the same page. We're going to do prediction using a regression equation. We're going to use an x value to predict a y value. And that predicted value we're going to call y hat. It has that little caret over the top of the y. Ultimately, what I want to know is, given a certain number for an individual, what do you predict an outcome will be? Since x is used to predict, we call it the predictor variable. The thing that we are predicting, the y value, is called the criterion variable. So we use x to predict y. In the real world, what this might mean is that we take a known value, let's say an SAT score, and we try to predict how well that person will perform in college. What do you predict will be the college grades for someone who gets a 550 on the SAT? Because the SAT is being used to predict, it is the predictor, and college grades or GPA would be the criterion. What is our criterion for success or outcome? When we make predictions, they'll never be perfect unless we have a perfect relationship between the variables, an R of +1 or -1. And that's very unlikely. In fact, if there is such a perfect relationship, it doesn't do us much good to make predictions. They're pretty boring. In other words, if it's daytime right now, what do you predict it will be 12 hours from now? Nighttime. You see how that's not a very useful or interesting prediction? So it is those less than perfect predictions that are most interesting to us in science. The error in our prediction, because our prediction is never going to be perfect, that error is related to the strength of the correlation. In other words, if the correlation is close to 1 or -1, our prediction will be pretty darn good and will have very little error in it. But as our correlation value drops closer to 0, the error in our prediction is going to become much larger. We're not going to be able to make as good a quality of prediction. Now, as we learned with correlation, we can square that R value to create an effect size. The R squared, or the coefficient of determination, is the percent of variability in the Y variable that is explained by variability in the X variable. And this will become important as we interpret our regression equation. So, if we have an R of 0.50, or somewhere around 50, if we square that value, the R squared would be 0.250. The way that we would interpret that is that 25% of the variability in Y, or let's say it this way, the variability in doctor visits, is explained by the number of apples eaten. 25% of the variability in Y, the criterion, is predicted by variability in X, the predictor variable. Now we have to be careful when we're making predictions to stay within the range of the data. In this example, I have some imaginary data of age and height. And what we see is a pretty strong positive correlation between those two. But the ages run from 4 to 12 years old. What happens if we try to predict outside of the range using that same regression line? If I were to predict using this line what your height would be at age 40, I predict that you'll be 12 feet 8 inches tall. Because my predictor value of 40 is outside the range of my original data, ages 4 to 12, that prediction is speculative at best and quite possibly incorrect. So we should never use our regression line to make predictions outside of the range. Here's a fun example of this from the XKCD comics. Here's a man talking to his wife the day after their wedding. As you can see, by late next month, you'll have over 4 dozen husbands. Better get a bulk rate on wedding cake. So yesterday she had 0, today she has 1. but that extrapolation is unlikely to continue in future days. So we should always be careful about predicting outside of the range. I will say that if you're slightly outside of the range, let's say the scores ran from 4 to 12 years old, predict for someone who is 13 years old, okay, we could make a prediction. It's going to be slightly speculative, but we could probably do it. But you shouldn't predict very far outside of the range of your data.